In episode 4 of Overview about Statistics, I continue from the previous slides that we focus in the beginning of the conclusions and work backward, and we cover about biases. In this episode, we will continue to have a closer look at the number 7, where we identify type of variable. For this, we really need first to identify what is the primary research question. So usually from the conclusions, we see there. Okay, so it's quite straightforward about that. Sometimes we look at the study title when we search for the literature. Sometimes we look at the objectives, but the first two sometimes is not reliable because some poor written research is contradict to the end, the conclusions. But when we cite a paper, we usually say something like, this paper found that, it's not this paper have a title or this paper have the objective. No, this paper found that. So the conclusions is the one that we can rely on about the research question. Now, if there are more than one conclusion, find the primary one, the primary aim. The aims to get the answer. That means the research designed for that purpose view designed in the way that conclusions or that answer is valid, not the secondary but the primary one. So don't cite a paper based on the secondary aim. It's just some cautionary. Try to make a question that is quantifiable if you design it. If you read a paper, try to imagine what quantifications or what magnitude that required to be estimated for that question. Either roles, you really need to know about this. Then if the primary research question is clearly stated or identified, we then look at the variable. Sometimes we call the dependence variable the primary one. The primary dependent variables is the study outcome. Sometimes we call the endpoint. Okay. It is the main findings that was used as the basis for the conclusions of the study, the primary study outcome. The main findings that was used as the basis for the conclusions of the study based on the primary outcome. It is the target of statistical inference. The primary outcome determine statistical inference to be used. It is the basis for sample size calculations. If you ask how the sample size is calculated, nobody can help if the outcome is not clear or not known. So it's very important. Where can we find that? The same as the previous one. It could be in the title. Vaccine efficacy, for example. How efficacy could be quantified? Oh, it's HIV infected or not infected. That's the outcome. This is question like, can this vaccine prevent HIV infection? vaccine is the independent variable, infection is the dependent variables, or the objective, or the sample size calculation. A well-written one will be, say, something like, based on the primary objective, the sample size was calculated to ensure that the confidence interval of the efficacy is precise enough. That's about the efficacy. So it's in HIV infections that calculate for that efficacy will be the outcome or the main findings in the results sections of the report or the abstract. So many ways, ensure that you identify the right one, because it determines all things here. So type of the study outcome is a key for selecting appropriate statistical methods. For what? For sample size calculation, for statistical analysis. Type of the studied outcome, or dependent variable, or sometimes called response variable, or events, endpoint. There are many names. But you need to focus on the primary outcome as the main one. There are 4 types. Okay, don't take a wrong concepts that many elementary books classify type of variables into 4 as well, but differ from mine. For example, I will write down here. For nominal, ordinal, interval, and ratio scale. It's differ from what I talk here. It's not the scale, it's the type of the study outcome. It's not the variables as a whole, not type of variables. It's the type of only the study outcome that determines statistics, as I said. So keep it in mind. Okay. What is the first one? Continuous, not nominal. Categorical. It could be dichotomous, that means yes or no, male or female. Oh, no, sorry. Yes or no, die or alive, dead or alive, cure or not cure, for example. Polytomous, more than 2 groups, like cure, remission, recurrent, fail, for example, the treatment outcome. Or ordinal, if more than is 3 or more and can be ordered, like severity in some sense, or things that can be ordered. So these are categorical. Numerical or Poisson count is the number of count or number of events, not continuous, not categorical, that event occur or not occur, but occur more than once. So we count the number of events. So we call numerical count outcome. And the last one is event-free durations. That means the events occur after sometimes, not just occur or not occur, but there are some components embedded in there, which is the durations from the start of the observations to the occurrence of the events. So more details about that by here, the continuous outcome, for example, how it's determined statistics. Determined by primary target of the estimations. The estimation is aimed to get what would happen in the larger population using what was found in the sample. So we summarize in the sample using for continuous outcome using mean or median, depend on what is the most valid summary of it. Sometimes we quantify how it's correlated to each other. Statistical, to handle this kind of thing, to get this, when we if we have no groups to compare, we might just estimate the mean and confidence interval. But if compare group, we get the mean difference using linear regressions, because usually we need to account for the covariates or the extraneous variables. And if not, linear regression can still be used for a simple mean difference. Or in the case where mean is not a good summary of that outcome, we use the median. We quantify the median difference and confidence interval using quantile regression, for example, which is a generalized linear model, a special type to handle something that is not usable by linear regression. An example of the outcome, for example, weight in kilogram, blood pressure, score of whatever, the level of whatever, etc. So, for example, green tea, effect of green tea on weight. Green tea will be the independent variables, but here we focus on the outcome. So weight is the outcome. We quantified the weight difference between those who use green tea or compare with not green tea, for example, mean difference obtained from this. Research question would be factors affecting birth weight, for example. So we can identify from the title, from the research questions about birth weight is the outcome, which is the continuous, and then looking for mean difference, The second type of the outcome is categorical outcome. As I mentioned earlier, there are three main groups about that: dichotomous, polytomous, and ordinal. Either of these, we need to quantify about the proportion so that we can have an idea how large percentage of the outcome in each group. Sometimes if the design allow us to get the risk or the probability, we can say the risk, interpret the proportions as risk, for example. So this is the primary target of the estimations. If we compare groups, we compare the risk, become risk ratio or RR, compare if the risk cannot be estimated due to the design is in the way that it cannot have a direct estimate of risk, we estimate the odds instead and compare odds, become the odds ratio as the target of the estimations or OR. Using what? Logistic regressions. I put this just the methods that's being commonly used or most popular. Details will be described later about choices of methods, but here, this is the common one, just to just to allow you to understand how type of the outcome determine statistical methods. And here is this example about categorical disease, yes or no, death, cure or not cure, factors affecting low birth weight. The previous one, factors affecting birth weight. So that means we treat the birth weight as continuous. Sometimes we have a cut point. For example, if lower than 2,500 grams at birth means low birth weight. So we now analyze the outcome using categorical or dichotomous outcome. The third one is numerical or Poisson count. The primary aim of estimation is the incidence rate per space. Some space, most commonly used space is person time. Using Poisson regression, and the coefficients of that model is the IRR, or incidence rate ratio. So for example, the false seems to be dichotomous, like false or not false. For example, some study about elderly fall. Elderly fall after discharge from the hospital, for example. Falls could be more than one falls, So rather than to treat falls, I will write this here. Rather than to treat falls as as dichotomous, I will put like ID, the participant number 1, participant number 2, participant number 3, and the data set. So fall. If we treat it as dichotomous, like fall or not fall, it will not fair. Some participants could fall more than once, So in this case, there are number of falls or episode of falls. So for example, if the first elderly falls twice, the second also falls twice, the third 0 mean not fall at all. The last one fall 1. You see, if dichotomous, it's not fair because it can just 0 and 1, but here there are 2. Now, there are another one called the exposure times or person times. I call it here is the PT. Times or durations under observations. Notice if the first one fall twice within 2 weeks, let's say 2 weeks, and the second participant fall twice within 6 weeks, the whole 6 weeks of observation, for example, here, the first and the second one, the same number of fall, but differ in number of observation times. So we will take number of falls. For example, if we use 3, number of falls here will be 4 divided by total time at risk or person times. It will be 14, right? 12 plus 2, 14. This is called the incidence rate, incident episode per person times. So this is the basis of numerical or Poisson count. The last one, the fourth one, event-free duration, sometimes we call survival outcome. Event-free durations, we go for median survival time and also the risk, but incorporate the times to the events into the calculations. There are more details if we have times, or in the more advanced class, talk about this. And if we compare groups, we compare about the risk of the events, incorporating time to events. That is the hazard ratio, or HR, using Cox regression. So this is the most common for this type of outcome. In the example, for example, the overall survival, the disease-free survival, progression-free survival, the outcome is dead or alive, but we cannot take it just dichotomous, because everybody dead. If we don't take account of the times to death, we will go to the invalid conclusions. So times to events is the fourth type of outcome. The time to event, that means event-free durations. The example of research question like factor affecting survival and many other things. So here are summary how the outcome determines statistics. If it is continuous, we go for mean or median. If categorical, proportions, prevalence or risk. If numerical count, rate per space, it could be percentile. In dental, it could be number of teeth decay per total teeth, for example. The space could be that. And the last one, survival analysis, median survival or risk of events at time t, survival probability at time t, compare the risk, become hazard ratio. And this determines statistical methods, and these are the 4 most common used methods for each type of the outcome. Linear regression to get the mean difference, logistic regressions to get the odds ratio, Poisson regressions to get incidence rate ratio, and Cox regression to get hazard ratio. We will talk in details in the class about how we plan about this in research, both sample size calculations and statistical analysis plan for the protocol, or statistical analysis method for the full article. See you the next episode.